Hi there, this is Mustafa Karim. My team name is Packing. We are doing the project of Getting Loaded, which is a trunk loading solution. My subsystems responsibilities are Arduino, motor driver, time of flight sensor, which is a distance sensor, and user interface, which is two push button and an RGB LED. This is the block diagram for our trunk loading solution, and the blue colors are my subsystem responsibilities. Programming the Arduino Uno, controlling two A4988 drivers with two NEMA 17 motors working together, controlling one TB6600 driver with one NEMA 23 motor, integrating two distance sensors, managing two push buttons for user direction input, displaying motion status using an RGB LED. We use two NEMA 17 step motors to drive the mechanism forward and backward in the x-axis. These motors are controlled using two A4988 drivers and always move together. A4988 driver that will be used in the demo with NEMA 17 is a compact stepper motor driver. It receives three signals from the Arduino. As shown in the picture, I will mention some of the important pins. First step, it sends pulse to move the motor step by step. The second one is direction, which is DIR, control direction for rotation, high or low. Enable, when low the motor is active, when high the driver turns the motor off, so I can disable the motor in software. Power pins, VMOT and ground is for 12-volt motor power. VDD and ground is for 5-volt logic power from Arduino. For the motor output, A plus and A minus, one motor coil, B plus and B minus, the second motor coil. The A4988 let the Arduino move a stepper motor using only digital signals. The driver handled the power switching to the coil. The second motor is NEMA 23. It's used for lifting the system vertically along the y-axis up and down. The TB6600 is used for NEMA 23 motor, which is a high current motor. This motor driver works similarly as A4988 motor driver. It receives step direction and enable signal from Arduino and controls the motor coil directly using high power. The only difference is that it's powered by 24 volt and doesn't need 5 volt logic power from Arduino. This is the distance sensor. It's going to be mounted to detect how far the system moves forward. When a target distance is reached, it stops the NEMA 17 motors and activates the NEMA 23. It uses pins SDA, SCL, X-Shot, and a 5-volt logic power from Arduino. There will be another distance sensor for high clearance, which is not used in this demo. It monitors vertical position to prevent the object on the lift from hitting the trunk. There will be two push buttons, one for moving the lift forward and up, and another one moving the lift down and backward. For this demo, only one push button will be used for testing the subsystem. We will be using RGB LED, green forward and lifting, blue returning backward, red reserved for emergency stop, but we will not use it in the demo testing today. This is the code that I'm going to use today. This is the library for distance sensor. This is the pins for NEMA 17 to control it. This is the pins for NEMA 23 to control it. This is the pin for the push button. This is the setup to power the Arduino. This is the NEMA 17 setup. This is the NEMA 23 setup. This is the push button setup using internal pull-up resistor. This is the sensor setup. This is allow me to check if the push button is not pressed, the system won't start. And this is reading the distance from the sensor, displaying it in the terminal. This is to see if the object is 3 centimeters far, so it would stop the NEMA 17 and start the NEMA 23. This is the run of NEMA 17 and this is the run of NEMA 23. This is my setup. This is my Arduino Uno. This is my NEMA 17. This is my motor driver. Drive the NEMA 17. This is my time of flight sensor. This is my motor driver for NEMA 23. This is my NEMA 23. Now I will press the push button and the NEMA 17 will run until I move my hand up and down and the distance is showing. Now I'll get it really close, so I stop the NEMA 17 and the NEMA 23 start to run. This is a quick top view video. I press the push button, the NEMA 17 on the right start moving. I get my hand close to the sensor. When I get really close, the NEMA 23 start to run and the NEMA 17 is stopped. Thank you for watching.